Yeah, hi everyone. My name is Jang Young-moon. I'm assistant professor in the School of Energy System Engineering at Jungang University. So this lecture is for the finite element method course. So that today is the first lecture of this FEM course. So I'm going to introduce the FEM course in English almost, but to introduce briefly our course in Korea so that I will slightly explain more details in Korean. So I'm going to introduce our lecture course briefly in Korea so that I'm continue to speaking in English. Our main textbook is this textbook, first course in the finite element method by Daily Logan textbook. It's the most famous book in the in mechanical industrial field, so that I think that it's a very simple textbook and most easiest book in the world. So please prepare this lecture material, main textbook. So I don't care you use a Korean textbook and English textbook. So that, however, I know that the sixth edition will publish it 2 years ago. So that depending on your financial situation, so that please buy the brand new book, or I don't care that I think that in the library they have fourth editions and then fifth edition in the library, so that you can also see this previous version's textbook. So however, if you have a problem to buy a textbook due to the coronavirus, I will send the PDF. So that please send the email. So but I cannot send to the full textbook in PDF. I will send or upload the partial part related to our lecture, so that so without any problem, please prepare this main textbook for your study in this semester. This is our syllabus, so that and then due to the something happened, so that I'm going to changing the details about so that I follow this procedure until the midterm exam, but are we changing this practical part into this part, so that I will prepare the theory. One day theory, the other day is practice. So maybe console. So maybe please memorize the procedure, our FEM lecture. So maybe depending on the procedure, I will upload it. I am going to assign some our homework, and then also we have we have some final term project using FEM commercial software. So I'm going to upload the previous term project. So maybe your situation, I'm going to assign the same term project in this year, or I'm going to changing the project topic. Maybe for the practice, so we are going to use a MATLAB and COMSOL software, so that maybe MATLAB, I think that all you guys can use the MATLAB software, so that it is because the FEM method we are going to handle some large size of the matrix, so that so we need some MATLAB. And also COMSOL software, I'm going to introduce how to install your computer, and then we are going to use the COMSOL software in our computer room. I bought some academic license last year, so maybe it will be very helpful for you to do the term project. So that we are going have some 2 exam, midterm exam and final exam, so that we have the main term project, so the final term project, so that this is a main key exam in this semester. So that, however, I'm not sure that we can have some midterm exam after the 7 weeks later. So, but depending on our Korean situation, I'm going to do, but depending on the situation, I will skip the midterm exam. But yeah, if we can meet in offline lecture room, so that we will have some midterm exam in this semester and the final exam both. Yeah, so before we start more detail about the FEM course, I'm going to introduce some subject. For example, fluid dynamics. Yeah, what is the fluid dynamics? Yeah, I think that you guys are already senior student, so in our department, so that you already learned about the details about fluid dynamics. What is the fluid dynamics? Yeah, okay, yeah. Fluid dynamics is physics to study the flow of air or some liquid flow. So normally I think that you guys last year learned about detail in the fluid dynamics lecture, so that we are going to know that how velocity of some fluid and how they moved to the by some depending on the pressure. Yeah, sometimes we can also handle some wave we treat as some fluidics. So yeah, also those kind of locate is strongly related to the fluid dynamics. Fluid dynamics is main subject in the mechanical engineering part. Next main topic subject is thermodynamics. I think that in our school student, mainly demonstrated in thermodynamics. It is because that all energy transfer into the thermal energy from the various types of the energy, for example, electrical and chemical and mechanical energy. So that I agree that thermodynamics is the most important subject in our department. So that I think that please study hard about the thermodynamics. Thermodynamics is some subject to describe some relationship between the heat and work. So maybe we have some thermodynamics lecture and combustion engineering maybe in this year, so that we are going to learn those kind of things. Also, heat transfer. Heat transfer is our main subject in our department also, so that they will we learned about the heat movement by conduction, convection, and black radiations, those kind of etc. So that some dynamics will dealing with the heat and work energies. So next subject is dynamics. So that it's a basics of the classic mechanics of the movement of the solid subject. So using we are learned about if some solid stuff will be accelerated, we can, if we know that initial position or initial velocity, we can determine the pathways of some solid subject or velocity field. Those kind of things. Also dynamics is a main subject in our department. So maybe vibrations, also more advanced lecture about this dynamics. I think the Professor O, he's mainly focused on those kind of drone systems. So that if you want to make those kind of drone, so you should understanding the dynamic motions of those kind of things. So that dynamics main key vectors. Also robot. Yeah, these days, robot is a brand state-of-art technology these days. So that dynamics is strongly, actually not these days. Few long time ago, dynamics is a main field in the robot industry field. So I was undergraduate student. I also very interesting in the dynamics, but it's too hard to understanding. It is because that some motion, for example, some acceleration, virtual acceleration, I don't understand these days yet. So my research mainly focus on the very static system. Last one, solid mechanics, actually, statics. Static. Compared to dynamic system, all solid mechanical system is keep continue their initial structure. So that means that their external force equal to 0. So that in this static condition, so solid, when we applied some force, the solid experience some resistance. This resistance is a stress. So that depending on the stress level, the solid structure will deform linear elastically or plastically, or will fracture. So that in the solid mechanics, we runs about the safety or mechanical stability of the some solid structure. So that in the some solid mechanics lecture or mechanics of the material, some more fracture mechanics. However, fracture mechanics is so difficult actually. So I think that if you are interested in the solid mechanics, and you can learn about fracture mechanics in the graduate school. So anyway, in our mechanical engineering department, we have 4 main subjects: fluidics, thermodynamics, and dynamics, and solid mechanics. So all subject is strongly, do you think that it's not related to each other? However, I strongly say that all physics is strongly related to each other. So for example, all common things is difficult. Both 4 subject is difficult, compared to other subjects. So it is because that we learned about various types of the PDE, but first time we learned about some physics or theory without knowing the exact physics equation. However, if you when you learn about more detail, we learned about several types of the physics. All physics is described by some mathematical partial difference equation. So those kind of partial difference, in the undergraduate course level, we learned about how to solve those kind of partial difference equation. However, real industrial field, the shapes or phenomena is design is very complex compared to our literature textbook. So we cannot solve it without using computer. So the computer aided engineering, CAE, is a method to solve those kind of physics phenomena. So for example, dynamics, fluidics, and solid mechanics, and heat thermodynamics. So I prepared some image. Let's have a look. This is a driving motion of the car. So car experience was reaction force due to the rolling of the wheel, and then due to the curvature of the ground. So we cannot solve those kind of motion by your hand. So we need computer. So this is a Recordine software to to simulate the dynamic motion of the car driving. Maybe Hyundai Motors, they also use those kind of simulation software before they designing some state-of-art car. Dynamics. Yeah, next thing is also there are some movement of the fluid air on the car surfaces. During the driving, the car will be experience large amount of the air resistance. So that to reduce the air resistance, they are going to design the car shape to reduce the perturbation of the air. So that this topic is strongly related to the fluid dynamics. And next images, it's a car crashing to the wall. After the crashing to the wall, car will deform very largely. So that this graphic shows maybe displacement or stress contour plot. So solid body will deform, maybe crack also we can easily expect it. Crack will be generated on the solid bar structure, so that we can simulate those kind of complex shapes by computer. So that our lecture mainly focus on the this also strongly related to solid mechanics. Using the computer, we are going to solve our main physics phenomena: dynamics, fluidics, solid mechanics. Although I skipped the thermodynamics in here, so that actually I don't think that thermodynamics needs a very complex simulation tool. Their theory is very simple. However, heat transfer is also use a computer-aided engineering techniques to show the temperature gradient. So that we need computational aided engineering. So that I strongly say that the FEM is one of the promising methods to use CAE. So actually to use a CAE method in our research field or industrial field, so first we need some 3D geometry modeling software. For example, CATIA or PROE. Maybe these days PROE changing their name to Creo. So AutoCAD is most famous CAD tool software. So that so using the CAD software, we can designing some geometry first. CAD. So it's essential CAD design to do CAE engineering. So and then after the design geometry, and then we imported this CAD file into our structural analysis software. So for example, ANSYS and Abacus and COMSOL. These days is most famous software for the analysis tool. So that this software is a CAE software. This CAD file only for the designing. This CAE software is to analyze the structure. So depending on your physics, we should use a different computational software. For example, to simulate or to analyze the multi-body dynamics, we use Adams or some Ricodyne. In the previous movie, I already shown you the Ricodyne software. So that also in the to analysis fluid dynamics, we usually use a CFS or Fluent. This is the most famous software to analyze the fluid dynamics. However, these days they are included in the ANSYS software. ANSYS software, which I already show you in the previous slide. So that Abacus is a classical solid analysis program. So that they have a strong point to analyze the solid structure. However, ANSYS is the next famous software tool. However, they added the multi-physics software. It is because that COMSOL can do the multi-physics simulation these days. So that ANSYS follow the COMSOL's strategies. So that's why I prepared the COMSOL software. It is because that these days we the single physics problem is rare. So that to analyze some practical problem, we should combine the multi physics, at least two more physics. So that, for example, in the solid structure, so that if you want to know the deformation by the thermal expansion or fluid solid interaction, so those kind of problem we met these days. So we need two more physics to analyze those kind of issues. So that these days I think the COMSOL has a strong point. Yeah, let's check the more detail. Yeah, Abacus software is their software name. Where is the Dassault system. Yeah, Dassault system is most famous software company. Maybe they also have a CATIA software. Do you know the CATIA? Yeah, so the CAD design program. So the main all analysis software company has their own geometry designing tool software. For example, CATIA and SolidWorks. Yes, also SolidWorks is joined in the Dassault software. And also ANSYS is most famous FEM software. So that they are their company is United States, and also they have there are various types of the multi-physics software. Also COMSOL is a software by Sweden company. So that COMSOL has a strong point in the multi-physics software these days. So I also prepared these tools. Actually Adina in the few years ago, we also have another FEM software, Adina software. This Adina is developed by MIT, but so that their solver is very strong compared to the other software. So it is because that this Adina software solver is used to the MSC Nastran or part1 software. This MSC Nastran software normally used in the in NASA. Do you know the NASA? In the ship research institution in the USA. So that they have when they designing the ship shuttle, they use this MSC Nastran software. So the Adina is a main company to develop this Nastran source code. So however, these days, due to the very low quality of the GUI interface these days, I don't think many research does not use this Adina software anymore. So I think that, but I also introduced those kind of software. And also in Korea, we have one company, Midas IT. Midas IT is also published the FEM software for the Korean company. It is because that those kind of software is so expensive than you expected. So that it burden to the very small company. For example, the construction company. So they cannot use those kind of Abacus or ANSYS software due to the financial problem. So 20 or 30 years ago, so that our Korean government supported some commercial software company to make those kind of FEM software. So the Midas company is one of the, actually only one company in Korea to to produce the FEM software these days. I prepared some introduction video of the YouTube, so let's see. Yeah, let's. I want to stop. I cannot see anymore. Yeah. 예, 잠깐 한글로 설명드리자면은 마이다스 IT 정말 좋은 회사입니다. 여기는 이제 방금 설명드린 저희 유한요소 소프트웨어를 개발하는 국내 유일의 회사라고 생각을 하셔도 될 것 같습니다. 이제 저희가 이제 유한요소를 공부를 할 텐데 이제 이걸 코드가 있어야지 이제 저희가 문제를 솔버라는 개념이 있습니다. 그 솔버를 개발을 잘해야지 빨리 풀려야 된다. 그 솔버 기술이 되게 중요하고요. 또 다양한 문제에 대해서도 했을 때 뭐 단순하게 풀릴 거라고 생각할 수도 있는데 정말 공부를 하다 보면은 이게 쉽지만은 않구나라는 게 있는데 이제 그런 것들의 기술이 접목이 돼야 되는데 이제 마이다스 IT에서 이제 자체적으로 개발한 이제 소스 코드를 바탕으로 이제 잘 디자이닝된 이제 소프트웨어에 잘 적용을 해가지고 이제 잘 풀릴 수 있게 정말 우리나라에서 많이 쓰고 있는데 이런 게 왜 쓰이게 된 걸까요? 사실 이제 앞에서 말한 이제 아바쿠스, 엔시스 같은 전 세계적인 기업입니다. 참고로. 네, 보통 프로그램 하나 사려고 하시면은 회사에서는 거의 한 1억에서 한 카피 사는데 한 1억 정도 들고요. 엔지니어가 여러 명 있게 되면 이제 한 10억 정도는 구매를 해야지 됩니다. 근데 어디에 쓰길래 10억 정도나 쓸까요? 사실 현실적으로 이제 거의 쓸 수가 없죠. 그런 가격이면요. 그렇기 때문에 이제 조금 더 낮은 가격에 구매를 할 수 있어야 됩니다. 우리나라 같은 경우에 대표적으로 이제 건설 경기가 이제 과거에 많이 이제 토목 건설이 이제 많이 됐었는데 이제 그때 당시 이제 설계가 너무 부족했었는데 이제 이런 프로그램을 써가지고 설계를 해야 되는데 가격도 비싸고 사용할 수 있는 사람들도 많지 않았고 하다 보니까 이제 낮은 가격으로 우리나라 스스로 설계할 수 있는 툴이 필요하다라고 해서 이제 마이너스 IT가 그걸 시작을 했었고요. 그러다 보니까 사실 이 소프트웨어는 이제 기계 분야나 혹은 이제 다른 분야에 비해서는 이제 건축과 토목에서 이제 주로 많이 쓰이고 있습니다. 즉 저희 우리나라들의 이제 건설사들이 이 프로그램을 바탕으로 이제 사용을 한 거죠. 그래서 이제 다른 엔시스나 아바쿠스 같은 프로그램을 최대한 이제 지향하고 이런 프로그램을 바탕으로 좋은 설계를 이끌어내고 있긴 합니다. 그래서 정말 좋은 회사입니다. 판교에 있고요. 네이버 아마 그 네이버 빌딩 경부고속도로 타고 가시다 보면 네이버 빌딩 보이시죠? 그린 팩토리 아마 거기 근처 정도에 이제 마이다스 IT라고도 있습니다. 아마 아프리카 TV 옆에 있는 걸로 알고 있고요. 예, 정말 좋은 회사입니다. 연봉도 생각보다 여러분 생각하시는 것보다 세고요. 이제 취업했을 때도 이제 좋은 회사라고 많이 알려져 있습니다. 근데 이제 역시 이제 좋은 회사도 여러분은 4학년이기 때문에 아마 많은 관심을 가지고 살아올 것 같은데요. 사실 뭐 여러분들에게 좋은 얘기도 해줘야 되지만 저는 대표적으로 이제 실질적으로는 이제 나쁜 얘기도 많이 해주고 있습니다. 대표적으로 정말 좋은 기사들도 많은데 한번 살짝 제가 처음 봤을 때는 없었는데 링크가 생기고 나서 이제 보시면 어떨까요? 예. 이런 것도 좀 있고요. 그 다음에 여기 있습니다. 저는 뭐 더 이상 길게 얘기하지 않도록 하겠습니다. 우리나라의 이제 유일한 회사기도 하기 때문에 여러 가지 장점도 있고요. 정말 좋은 회사입니다. 많은 기술력도 갖고 있고요. 그래서 아마 여러분들이 조금 더 이제 만약에 유한 요소 같이 이런 이제 수치 해석에 대해서 조금 더 관심이 있으시다고 하면은 이런 쪽으로 더 공부를 하셔도 이런 쪽에서 회사를 취업을 하실 수도 있다. 심지어 뭐 이런 개발하는 쪽에 가셔도 되고요. 이거를 잘 응용하는 쪽에 가셔도 됩니다. 모든 소프트웨어가 모든 문제를 해결해 주진 못합니다. 그렇기 때문에 저희가 실질적으로 코드를 자체적으로 개발을 해서 하는 경우도 있고요. 좋은 툴을 써가지고도 사용하는 경우가 있는데 조금 난 이런 쪽이 이제 설계 이런 쪽이 컴퓨터 에이드 엔지니어링이 좋다라고 하시면은 이런 쪽에 관심을 가져주셔도 좀 좋을 것 같습니다. Let's back into the lecture again. So that let's back to our lecture again. I also prepared one more video. I'm going to show some video about crushing experiment. So that between the truck and car. So let's check the difference of this video movie. First, car crush. So car will crash to the backside of the truck. So that what is the difference between the two crashes? Below part compared to the upper part, below part crash is more safer for the driver. What makes difference? Let's see the one more video. During the car crash, the first crash make some critical safety issues for the driver. However, second car crash does not make critical safety issues for the car driver. What is the difference between the two car crashes? First car crash, the car inserted into the backside of the truck. However, second car does not penetrate the truck. Yeah, car is the same. However, truck also same, but they have a different safety bar in the B side. Yeah, let's check the detail. Yeah, in the first car, truck has some protective bar. Second car also has the same protective bar. However, they have some supporter, more supporter. Yeah, due to the adding this supporter, this car crush. Yeah, this support increase the safety compared to the first one. Yeah, so this protector does not analyze the crush impact, so that due to the high impact, the bar does not sustain their initial structure, so that car penetrated into the truck below. So however, this due to the adding the supporter, so that supporter sustain their structure, so that deformation is difference these two protector, so that how they so that's why important things to analyze the solid structure. So what is the structural analysis? During the undergraduate course we learned about how to deform those kind of solid structure. So that we learned about the beam theory or truss. Truss is a deformation only in the tangential direction. Beam is a perpendicular direction, so that we learned about the deformation of the solid structure. However, also car deformation or protective supporter deformation, also solid deformation. So however, their shapes is very complex compared to the beam or truss structure. So that in these cases, how can we solve the solid deformation of the car frame of the protective bar? So it's impossible to calculate it by hand. So that FEM method is a numerical technique for the finding some approximated solution on in this complex geometry. So that so why we need a FEM technique? Actually numerical technique. Numerical technique is for the solve some ordinary difference equation or partial difference equation. And then among the various types of the numerical technique, FEM most promising method. It is because that we can apply this finite element into those kind of complex geometric very freely compared to the other numerical techniques. What is the FEM? Finite element method is some discretized method. For example, you guys already know that the area of this circle, it's very simple. Maybe the circle area is a pi radius square. So that, however, how can we obtain those kind of equation? Finite element method technique is some discretizing the geometry and assembled this discretized element. For example, let's think about this triangle. We know that the area of this triangle. How can we know that? Half of the r square and sine theta. And then we have 1, 2, 3, 4, 5, 6, 8 maybe, so that we have 8. Maybe depending on the size of the triangle, we can say that maybe these two cross-section area are very similar. When we decrease the angle of the theta and then increase the number of the triangle, so at the cases maybe say that we can say that number of the triangle go to the infinite, theta go to the infinite to 0. At that cases, these two summation of the area of the triangle and the area of the circle may be approximately very similar. So that this is a way to how to use the FEM method. So that if we have some house or building structure, so that we already know that those kind we use some very simple block. For example, Lego. We can make those kind of solid buildings by very small size of piece of the block. So that FEM method use a very small element and then assembled this element, so that designing the whole part. To solve the whole part, complex geometry, it's too difficult to obtain the solution. However, to obtain solution in the very small size piece of the block or small element, it's very easy. So that assembled those kind of element also easy. So that computer can achieve the goal, for example, cross area on some analysis of the solid structure of the complex geometry. So that FEM method is origin those kind of basic theory. So that to assemble those some element, we need a very simple element. In the one-dimensional problem, we are going to use a line element. So that if we have some truss or bar, at that time, so that we discretized several parts of the block. At that cases, we say that this is a one-dimensional element. So that we are going to say that to describe the two-dimensional surfaces, we are going to use some plane element. So that we can use a square element, or depending on the situation, we are also use a triangle element. So that to describe the 3D spaces, we are going to use these brick types of the element or tetrahedron element. So that this is a example of the tetrahedron element. So that it is difficult to analyze this whole solid structure. However, maybe the very small size element, we can solve this part, and then after the assembled, the solution maybe will be saturated exact solution. So numerical solution have some error compared to the exact solution. However, some error is negligible depending on your numerical techniques. So I also prepared some example on the concepts of the FEM in the solid mechanics. During the solid mechanical lecture, we learned about the deformation of those kind of truss bar. This truss bar has a different cross-section area depending on the position. So that some truss solid structure which has a same cross-section area, at that cases we can easily say that deformation. However, when they have a different cross-section area, I thought that it takes a lot of time to obtain the exact solution. Maybe we should integrate it depending on the cross-section area. But however, FEM technique. Let's see the FEM method main technique is discretize. Discretize means divide by the solid subject into the very small piece of element. So that here we use a very simple beam or truss solid subject. So that maybe when we use many number of the block, the shapes may be approximately same. However, to easily understand, I use a very few number of the block, so that maybe in this solid model also shows a very similar deformation compared to the discontinuous model. So that at that time we already know that of the deformation of the behavior which has the same cross-section area. So that at that cases the deformation is looks like deformation equation is looks like this. So that at that time, so that we can finally obtain the those kind of equation, or sometimes we say that this is a delta. So that after then obtain the some deformation of this block and obtain the deformation of this block, and then we sum this block, so that this is a total deformation. So that those kind of way we are going to use a FEM technique into our continuous system. So that although I say that assembled is a very simple summation of the result, however, so this deformation is strongly, this solid structure is strongly affected by next to the block, so that we cannot say that this is a simple deformation. So that depending on the situation, the result is become those kind of matrix form. So we are going to say that more details. So that anyway, so that we obtain some deformation, the exact displacement or strain on in the specific body or discretized body system. So that this result is also discretized. However, in the real exact solution is very continuous. However, it's very similar. So that although they have some error depending on the position, however, on the nodal point, the result maybe we can say that same. So that this is a way to use the FEM method, and then limitation of the FEM method. To reduce those kind of error. So that so that the only simple way to increase the element. So very simple way. It is because that to calculate it or measure those kind of block deformation, it's very simple. So that we can use the for loop. It is because that duplicated work. So that computer like those kind of duplicated work. So depending on your computational cost, we can solve the very good result. So anyway, our lecture FEM course is strongly related to the solid mechanics. The solid mechanics is a part of the continuum mechanics. Continuum mechanics means that all object is very continuous media, or solid or liquid. We assume that all matter is continuous. So that one of the parts is solid mechanics, and the other part is we call the fluid mechanics. So that in the solid mechanics we also handle the if the solid deformed elastically, we call the elastic solid material. Sometimes solid deformation shows in elastic behavior. At that time we call it the plastic deformation. So that, however, in our undergraduate course, so that we only learn about elastic deformation of the solid mechanics. And also I think that similarly fluidic dynamics, they also you guys learn also only Newtonian fluidics maybe, right? So they don't have any volume changings due to the pressure difference. So that this is maybe Newtonian fluidics maybe. So however, that means that FEM method is not only for the solid mechanics. So is for the continuous mechanics. So that means that FEM technique can be applied to the fluidic dynamics and solid mechanics both. So that if you are interested in the fluid dynamics either, so you can use the FEM method. However, compared to the FEM method, fluidic dynamics has a more good technique for the numerical analysis, so that I'm going to introduce the more details. So numerical FEM method is one of the techniques of the numerical analysis. So that among the various types of the numerical technique, first is the FEM method. Second is the FDM method. I think that FDM is more famous than FEM method. And also next is a finite volume method, and then the boundary element method, and etc. So that in this lecture we are going to learn about what is the FEM method. However, I think that you guys already know that concepts of the FDM method. So that I prepared some example of the FDM method. FDM method. I think that in 2 years ago, last year, I think that you guys learned about heat conduction or some those kind of pressure distribution of the electrostatic equations in 2 years ago, maybe. This is 2 years ago, maybe 1 year ago. You guys learned those kind of physics phenomena in the major lecture. So that to obtain the solution, I think that you guys used the FDM method. So that's I prepared some slides about the FDM method. So that first, elliptical equation. In engineering field, typically used to characterize the steady state or some static conditions of the boundary value problem. So that we have several types of the PD equation strongly related to the elliptical equation. So to show what is the elliptical equation, I prepared some heat transfer example. What is the heat transfer? Heat transfer means that heat energy move to the from the low temperature, high temperature to the low temperature is a heat conduction. So that to know that energy equation, we set the representative volume element in here. So that input is a Qx, and then volume is looks like cross-section area looks like this, and the total time dt, and then input is a Qy. Input is Qy. Their cross-section is a delta x, delta g, and time delta t, and output is a Qx plus delta x, and cross-section area looks like this, and time, and output heat flux, and looks like this, the cross-section area and time. So that input and output of the heat energy almost equal, or sometime become 0. This is an energy conserved equation. So that after the organizing this equation, we obtained those kind of some finite different equations. So this equation looks like this, some elliptical equation. So and then heat transfer can be described looks like this. Heat transfer is heat flux is proportional to the some coefficient and the temperature gradient. So that after adding this heat transfer to the elliptical equation, we finally, after the cancel out some coefficient, we can obtain some Laplace equation. This is a Laplace equation, some grade Laplace equal to 0. So that if they have some function over some constant, they become Poisson equations. So that this is a main governing equation of the heat conduction problem. So that I think that you guys know that what is the heat transfer. So that to solve this equation by numerically, we should changing this Laplace operator to some discretized equation. So that what is the derivative, second derivative of the temperature, so that we can use the discretized form, so that this second derivative with respect to the y become this part, so that this Laplace equation can be discretized equations. So that so the domain is look like this, and then we use some very fine element or node, so that delta x and delta, if we have a same delta x and delta y, so that the equation can be looks like this. So depending on the nodal point, we have several equations. So that let's think about, first we have some first equation, specific point, maybe this, when you selected the first nodal point, so that we have a plus and 4 minus T1. So, and then this part we have a specific boundary condition 75 Celsius and then 0 Celsius. That equation looks like this. And similarly, we can set the equation at every nodal point. So that depending on the number of the nodal point, we have 8 nodal point. Finally, we obtain the 8 equation, maybe 1, 2, 9. So we have 8 equation. So this is a 8 by 8 matrices, so that we must solve it. So that I prepared some matrices. So I added the coefficient in the 8 by 8 matrix, so that this is a B part, is a solution part. So that to obtain the solution, so that we take inversion of the matrix A and multiply with B, so that this solution is looks like this. So that next part, that we should apply the exact numerical solution into the appropriate position, so that this part becomes second nodal point, this one second nodal point, this one third nodal point, so that we obtain those kind of solution, calculated solution. So that to visualize it, so I use a contour plot, so that some contour plot looks like this. This part is 0 and 25 to become 75. So this is a result. So that those kind of way, so we can use we can solve the Laplace equation. This method, this part, this part is a second derivative of the some function. This, when you're changing this equation to looks like this, this method is a finite different method. So that, and then after the changing some equation into the finite discretized equation, so that and then assembled part and then solution part is just numerical technique, so that you don't care about it. So that similarly FEM has a similar technique, so that we are going to have some equation, Laplace equation. We are going to take some integration, so that applying the integration, we are going to obtain some discretized some equation. Similarly, it is because that integration, we can easily divide this equation to the several parts. So those kind of technique we are going to use in our FEM course. Today I prepared some MATLAB code to solve some FDM method. However, it's not the important part. I'm going to skip it out. So anyway, so there are many Laplace equations in various types of the physics phenomena. First is an electrostatic equation. This electrostatic equation looks like this. The final equation is a Poisson equation. That means that if you know that boundary value problem of the voltage, maybe in this part ground voltage and then specific voltage, at the time you can obtain some voltage contour. Also, this is a wave equation, so that we can changing this wave equation to the discretized form. So we can also solve the time dependent equations, or some also compressive stress shows some those kind of Laplace equations. So anyway, so we also obtain some pressure distribution of the or velocity field of some of the fluidics. So that anyway, using the numerical technique, you can obtain some very complex some equation solution in the complex geometry. So that FEM, that's why we use the FEM method. But anyway, so that compared to the FEM, FDM has some limitation. It is because that they must have a well organized element, for example, like a rectangular element. So that at that time, let's think about, if you want to analyze the circle shapes, using those kind of rectangular element, they have a lot of error compared to the exact solution. However, those kind of triangle element, so in the case, their numerical error will be decreased compared to the FDM method. So compared to the FDM, FEM has a strong point of the shapes of the element. So next time maybe we are going to learn the maybe few lecture later, so that we are going to learn about the various types of the element. But so just memorize those kind of thing. So to compare to the result, I prepared some element example of the finite element method, so that if we have some Laplace equation, those kind of equations, so that at that cases we are going to assume that this element has some those kind of interpolation function. Why we need those kind of interpolation function? It is because that this U nodal point, specific nodal point, has a specific value at nodal point. However, between the nodes, I mean that in this region, we don't know that exact solution. So we are going to interpolate it by the specific nodal point. It is because after the calculating, we are going to know that exact solution. So that means that we have some coefficient, unknown coefficient in here. That means that if we have a specific value, value, we can obtain this coefficient. So that those kind of way we can define the interpolation function U. So that after the inserted this interpolation function here, so that adding some integration method, so that integration, this equation become 0 in the domain R. However, due to some approximation, we cannot say that the integration of this Laplace equation or domain cannot be, it is hard to become 0. So that we added some coefficient after then those kind of techniques, so that we obtain some FEM technique. But it's hard to difficult to understanding the first time, so that next time I'm going to introduce the details, so that like those kind of technique we are going to use it in the FEM method, so that finally we are going to obtain those kind of KUF matrix equations. So it's not important. However, yeah, just memorize the from the strong form equation. What is a strong form equation? Is those kind of equation. Yeah, equal 0. So that this is a strong form equation. So that we are going to use this strong form equation, take integration. So equation become weak form equation. So that using the some various types of the FEM technique, we are going to obtain the some matrix form equation. So this is a procedure of the FEM method, but it's not a big deal, so that you don't worry about it. So it's time up, so that I stop this lecture first. I'm going to continue to the lecture. So see you next time.